Welcome everyone to today's event. We are excited to present Meet the BioBuddies with Homegrown Solutions to Synthetic Materials. My name is Anya Scholes, and I am the Program Director for Biology and Design at the Tech Interactive, and I am lucky enough to be your host today. So to start, I just wanted to make sure we thanked some of our important sponsors. NetApp is a sponsor of our Youth Climate Action Summit. And I also wanted to make sure to thank the National Institute of General Medical Sciences for our Science Education Partnership Award and support of the Biotinkering Lab. And now, it is my sincere pleasure to introduce you to a trio of inspiring Bay Area high schoolers who call themselves the GIY BioBuddies. These young women are a garage makerspace team that has won multiple awards for their innovative biodesign projects. In fact, in 2019, they were runners-up to the grand prize at the International Biodesign Challenge Summit held in New York City. So with that, I'm going to turn it over to Anne Hu, Emily Takara, and Trisha Satesh to tell you all about their work.
Thank you, Anya, for that. Hi, I'm Trisha.
I'm Emily.
And I'm Anne. We're the BioBuddies. Just to let you all know, we're going to be using the chat today to send you guys some resource links and also some definitions for scientific terms we'll be using. So we're the BioBuddies. We're a garage makerspace team from the California Bay Area. We all go to different high schools, but we meet up outside of school to explore some biomaterials. We created a perspective, approachable, and affordable bio toy kit that sparks, sustains, and grows interest in sustainable design and biomaterial crafting. Did you know that 90% of toys are made of some sort of unrecyclable plastic, and that the average toy fad only lasts for 8 months? You can imagine how much plastic waste comes from the toy industry. So with our kit, BioBuddies, we're hoping to engage and focus the public eye in biodesign and environmental sustainability. We're doing this through exploring the intersection of biology, art, and making through simple crafts. All of the activities in our kit are created to get people of all ages started in exploring biology and biodesign. So we started our own biodesign journey in the fall of 2018 when we decided to enter in the 2019 BioDesign Challenge. The BioDesign Challenge is an international design challenge that just opened up to high school students last year. In the BioDesign Challenge, teams use biodesign, which we define as the design with, for, and of biology, in order to create a new system or new product. We're going to go ahead and show you guys the video submission for our final product at that challenge.
In a world where plastic rules all, 90% of toys are made of some sort of unrecyclable plastic.
Our brave biomaterial rebels, Fungus and Scooby, have come to save our planet. Together, they will battle the evil forces of plastic. But wait, they can't do it alone.
Join their mission of ridding the world of plastic, one BioBuddies kit at a time.
We're the BioBuddies!
Our mission is to provide you with eco-friendly toy kits to explore, play, grow, and create with biomaterials. As the world is becoming more aware of environmental sustainability, it's time to move away from plastic. This is where biomaterial design comes in to save the day. Our biomaterial growing kit incorporates science, nature, and art to make biodesign more approachable.
We've designed 2 biomaterial growing kits, Scooby and Fungus. Scooby is a Kombucha growing kit, and Fungus is a mycelium kit. Each kit includes the necessary supplies to grow the biomaterial and explore with it.
The average toy fad lasts 8 months. Our goal is to create a sustainable kit that can be played with, explored, and developed to sustain interest over a long period of time. The entire exploration journey cycle is accessible, educational, and fun.
We tap into the waste stream by feeding our cultures with used coffee grounds, sugary drinks, and tea leaves. First, users grow their biomaterials.
Then they can play and explore through personalized projects with their materials. Of course, not all projects will succeed, so we encourage users to celebrate their fails.
In the future, we hope that we can sell our kits online or even in retail stores like Target to people of all ages. As our kits don't fit into a specific category, we think that they would best fit into the craft or miscellaneous kit aisle.
Help us save the earth by redesigning the toy industry.
BioBuddies out!
All right, just before we move on, I forgot to mention earlier, if you guys have questions at any time, you can put them into the Q&A. We'll try to answer them as we go, but we'll also have a Q&A at the end of our presentation. Okay, so you guys just watched our video for our submission. When we got started in biodesign, we had no experience whatsoever. We didn't even know what biodesign was. So we got started at the biotinkering lab at the Tech Interactive. At the biotinkering lab, they showed us around and they showed us their kombucha cultures and how they were growing mycelium. And after that, we were inspired and we wanted to start growing our own biomaterials. So back in the garage makerspace, we started growing kombucha and mycelium and got ourselves familiar with making and crafting. We also conducted some biomaterial craft workshops to engage the public and to get feedback. While we were doing all these explorations and crafts, we hadn't yet decided on what to do for the biodesign challenge. And then we realized if we were having so much fun crafting with biomaterials, why not just make that into a kit? That way people with minimal experience like ourselves could also explore and create with biomaterials too. Currently, although we're not selling our kits, we are creating online resources so that people can explore biomaterials in an affordable way. We've been updating our website with the new biomaterial growing activity videos and illustrated instructions. We're always working to make biomaterial exploration more accessible. In the bottom right corner of your screen, you can see a biomaterial kit that we sent out through some food boxes. So back to the kit. We have two parts of the kit. The first is Scooby or kombucha, and the second is fungus or mycelium. All of our activities are designed to enable people to grow, explore, play, and create with biomaterials. The first half of our kit is called Scooby, which is also kombucha leather. Scooby stands for symbiotic culture of bacteria and yeast, and is a bacterial cellulose that is grown by kombucha. If you've ever gone to the grocery store and seen a bottle of kombucha, the health drink, that's what Scoobies grow from. Symbiotic means that the bacteria and the yeast work together and they build a kind of raft at the top of the kombucha culture. That's the Scooby. If you harvest a Scooby, it dries and becomes thin and turns into a paper-like material that we call kombucha leather. The second half of our kit is called fungus. It's our mycelium part. Mycelium is a fungi's root-like structure and it feeds off of a substrate. And this may sound a little bit circular, but a substrate is anything that mycelium can eat. For example, we fed our mycelium coffee beans, cocoa husks, and even dried ramen. Mycelium grows into whatever shape you pack it into. We pack them into different molds, which are just different plastic containers. So if you see on the bottom left of your screen, the thing that kind of looks like a weird spaceship, that's actually just from a sink strainer. And on the bottom right, that's a mold that we designed ourselves through Tinkercad, which is a 3D printing website. Now we're going to go a little bit more into depth about each biomaterial, how you grow it, and the different activities that you can do.
Okay, let's start off with kombucha. So on the top of the screen, we have a link to our illustrated instructions if you are interested in growing kombucha on your own at home. So most of the supplies you'll need are pretty easy to get, such as a pot or ladles, etc. And you're going to need to have some isopropyl alcohol, gloves, and eye protection just to make sure that you're being sanitary and safe while you are making your kombucha batch. And the main ingredient in this process is a bottle of kombucha, which you can find at most grocery stores for about $3 to $5. And kombucha can come in many different flavors, but it doesn't matter when it comes to making your culture as far as we know. The first step, as you can see here, is after you've cleaned your work surface, you're going to want to make the sugary tea, which is essentially the food for the kombucha to grow on. We recommend using green or oolong tea as it's the least smelliest when it comes to growing your culture at home. And the second step is to mix your store-bought kombucha with the tea, which essentially creates your culture. After you've mixed them together, we recommend to place a coffee filter on top of it, as it's important not to seal your jar really tightly, as it can cause for some conflicts with the kombucha culture in the jar. And we've also drawn on cute little faces onto our coffee filters just to personalize it a bit. The fourth step is waiting. You're going to have to wait for about a couple of weeks to let the Scooby grow onto the culture. And once it's grown to about 1/4 of an inch thick, you can harvest it out and let it dry, and it will eventually turn into kombucha leather. So here's a little bit of the science behind kombucha. Kombucha has been around for nearly 2,000 years, and it originated in China, and since then has spread to many different parts of the world. It's a very popular health drink as well. So a SCOBY, like we mentioned before, a symbiotic culture of bacteria and yeast, consists of acetic acid, bacteria, and brewer's yeast. This is what creates the cellulose raft that sits on top of the kombucha culture. They both allow for fermentation to occur in kombucha, which is a chemical process where the carbohydrates such as sugar or starch turn into an alcohol or acid. In our kit, we've created 4 different kombucha-related activities related to popular and existing toys such as Legos and dolls. We've also used the scraps of kombucha leather so that even small fails are being incorporated into activities. And all of our resources such as illustrated instructions, YouTube tutorial videos, templates, and more are available on our website, so you should definitely check that out. Our first activity are kombucha wings. So users can place the kombucha leather onto 3D printed wings that can snap onto Legos. This is a great way to incorporate something unfamiliar, such as biomaterials, kombucha leather, to a toy that many people are familiar with. Our second activity are kombucha kaleidoscopes. The user can assemble, personalize, and place kombucha leather and any leaves or other plant material onto a petri dish. This activity aims to draw nature into the user's journey. Third activity are laser cut paper dolls. We have 3 styles of laser cut paper dolls, and all the user needs to do is place the kombucha leather behind the outline of the doll to dress it. You can also add any accessories onto the top, such as the picture shown on your screen. This is a great way to use scraps and fails, as sticky, unusable kombucha leather can be placed onto the paper without needing glue or tape. Our fourth activity are kombucha lanterns. You can take 6 or 8 circles of kombucha leather with glue to create an LED lantern. This can easily be personalized and is a great combination of incorporating both simple circuitry and biomaterial assembly design into a user's journey. Each project is a unique combination of art, science, and the creativity of the user. So back in April of 2019, we conducted a kombucha leather workshop at the Biotinkering Lab. Yay! During the 2-hour workshop, we offered 3 different activities from our kit, and we had about 100 participants ranging from really young children to adults. This is a great way for us to test out our activities with a diverse audience of people and receive useful feedback, which we eventually did use when we were finalizing our kit activities.
Okay, and then this will go into how to grow mycelium at home. So the process we have on photos on the screen is the way we usually do it, but you can also try to grow it from straight from scratch by buying reishi mushrooms from the store. So the way we usually start is the first step is buying a bag of mycelium substrate, like we said, is like mycelium food that has mycelium in it. And we would recommend Grow Bio, which is from Ecovative. So you order that online. It's about $13, and it comes and looks like just a bag of bark, but it actually has dormant mycelium in it, so it's not active yet. But to activate it, there's instructions right on the bag itself, and the Grow Bio website has really good videos and illustrated instructions. And basically, to activate it, it's going to be a mix of flour and water, and you're going to shake up the bag and then partially close it, and then after 2 to 3 days, the mycelium should start eating the bark, and it'll start looking white. So once that happens, you can do step 2, which is pressing that mixture into a mold. And these can be anything, like we said. You can recycle containers from around your house or make your own. And once you press that in, you want to make sure everything's really clean, by the way. You should wear gloves because bacteria in your hand is really bad for it and can kill the mycelium. So make sure everything's sprayed down with rubbing alcohol, your hands are clean, and wearing gloves. And then you put your packed molds into a bag to store and grow, like in number 3. And you're going to leave about an inch or so of the Ziploc bag open so that it can get some air, and leave that to grow for anywhere from 5 days to 2 weeks or more. And you're gonna know when it's grown. It's gonna look like number 4, where it's very white and they'll seem like really solid. And the white part is like the pure mycelium, where it's consumed the bark. And from there you can pop it out of the mold, put it on a baking tray and bake it in the oven at about 180 degrees Fahrenheit for around an hour. And this will kill the mycelium and stop it growing. And so you'll have your mycelium creation, and then you can decorate it and add craft materials like we have on number 5. Okay, and then more information about mycelium. Mycelium is the largest part of the organism of fungi. Like the mushroom itself is just the fruiting body. And the mycelium is made out of hyphae, which is these really small like filament that branches out, and that's what you see that is white. And fungi are actually not plants or animals. They belong to their own kingdom, and kingdom is a classification of organisms, and the biggest organism on Earth is actually a system of mycelium and fungus underground. And these structures and systems are really important in the forest because they actually not only help break down and biodegrade dead plants and trees, they also help trees communicate. And fungi are actually more closely related to animals than plants. Okay, and then the activities are more like different ways you can grow your mycelium. So the first one we have is pretty standard. It's recycling containers, like we have plastic bottles, chocolate molds, and you press your mycelium in that. You just have to like spray it down and make sure it's clean. And then 2 and 3 are like customizing your own molds. And in our kit, we would imagine sending you customized vacuum forms, which we've created. And you would press those, and then you could mix the top and bottoms, like in number 2, so that you could have different legs and a different top. And then when you glue them together, you would have your own customized planter. And then number 4 is growing an incubator for mycelium out of mycelium. And this is kind of a general prompt, I guess, to give an idea of where you could go after you've kind of been introduced and gotten familiar with biomaterials. So an incubator is like an enclosed system that is like the perfect environment for growing something, and in this case, that would be mycelium. So you would want it like kind of on the darker side so it doesn't get overheated, but you also want it a little warm. So the one in the photo includes a heating pad. So on our website, there's kind of more information about the process you could go about doing this, but there's some coding and wiring the heating pad to the board. So it's kind of a neat exploration in combining tech and bio and crafting. And kind of building off the idea of the incubator, where we hope to kind of introduce you into biomaterials so that you can be familiar with it and then go on to explore it and expand the field in whatever way you can. So what people are doing right now with the biomaterials we're talking about include working with mycelium. Like MicroWorks is creating sustainable leather from mycelium, fungal leather. And then Ecovative does mycelium packaging as a replacement for like styrofoam, which is really bad for the environment. And then At Last from Ecovative is creating vegan bacon from mycelium. And then kombucha, there's also lots of explorations with this. A lot of them include like fashion, Suzanne Lee with her bomber jacket, and then the one in the middle is really neat. Someone did a cosplay out of kombucha leather, because cosplay is very single use. And then also there's like ideas about exploring art and the idea of this living kind of skin-like material and exploring that. Okay, and this is some of our social media information and resources. And then we can open up to answer questions from the Q&A.
Yeah, if you want to stay updated with what we're doing with the kit, make sure to follow us on Instagram and check out our website as well.
All right, I think we're just gonna go through our Q&A questions. So we have, what's the biggest thing you've built with mycelium? Anything you're interested in trying out next? Ooh. I think the biggest thing we've built is the incubator, right?
Mm-hmm. Yeah, I think it's MicroWorks that was looking at growing bricks and how that would impact like architecture and stuff, which would be neat for what we're thinking, what we'd like to grow. I don't know, the fashion side seems cool.
Yeah, we haven't really seen that many applications with mycelium in fashion. It's more of kombucha related to fashion, but we want to explore different things that we can do with it too.
All right, our next question. How can I tell the difference between mold and fungus if I try to grow these? It seems like white can look like mold.
I think pretty much every time it's white, you're doing it right. Like the mycelium will look like the solid structure can look kind of fuzzy because it's made of like these filaments. Yeah, and showing that.
I'm actually growing some mycelium right now, so I can just show that here. It's very white, but if you're growing mycelium and you start to see green, then that's like a bad sign because then you let in other bacteria and other mold into your growing biomaterial thing.
Yeah, so in general, if you see a lot of green or yellow, then that's the mold. Or sometimes it's gray, but I don't think we've ever seen any white mold.
And a remedy to that, so you don't have to immediately throw that away, you can try spraying with hydrogen peroxide. And a lot of times that'll help just kill that mold. If you just spray a little bit, then the mycelium can continue growing.
Okay, our next question. If this person wants to try one of these, which one would they recommend, mycelium or kombucha? Kombucha we recommend kombucha. It's very easy to explore with, and it doesn't necessarily require a lot of attention, I guess, compared to mycelium, but we'd recommend you start off with kombucha first.
Yeah, especially because once you have your batch of kombucha in a container, you can just keep pulling off those rafts of Scooby, and it'll keep growing. So that's a really nice, like, circular, continual stream of material.
Yeah, we've had some cultures going for like 2 years at this point. It's pretty cool. Okay, how can we support you in making these kits more widely available? That's so nice.
Please email us. We're like working on so right now we're just working on making it like on all of our resources available online so that anyone can do it and they can do it at the comfort of just like getting their own materials. But the one limitation with just following like our online resources is that we don't provide the biomaterials, kombucha or mycelium. You would have to get that on your own. But if we were to make them more widely available, we would definitely try and include certain biomaterials in the kit as well.
Yeah, for now, I think just keeping up with what we're doing, like especially our Instagram, DIY BioBuddies, because that's where we'll be updating like what we're doing and where we're at. For now.
Okay, what are you excited to learn more about in the biotinkering world? Ooh.
Everything.
Yeah. Like Trisha said, the fashion side is very interesting because I feel like there's a lot more awareness about fast fashion. So learning about how people are taking mycelium and kombucha and turning those into fabrics is really interesting.
Especially now with like PPE and like the new fast fashion is like those disposable masks. So that's interesting to see what people are exploring with that.
Okay, are there any other biomaterials you would like to explore?
Yeah, so I think it's Ecovita's website. Is that the one with all the, or Materium?
Materium.
Yeah, I would really like to explore some of that. There's like avocado and like eggshell materials.
Bioplastics too.
Yeah.
poured with a bit of bioplastic, and it's really cool because if you compare both the plastic and bioplastic, they're pretty similar. So,
Yeah, it'd be nice to explore some more durable biomaterials. Mycelium is really durable and light, but kombucha is kind of floppy, so it might be nice to see what other maybe waterproof materials we can find.
Mm-hmm. Okay.
Okay, is kombucha really comfortable to wear? It seems like it would be sticky.
Yeah, the way we grow it.
Yeah, we grow ours sticky, but we know that it's possible to grow it not sticky if you use less sugar.
Yeah, and like even coating with wax, which we've seen, like really changes the texture and the material.
and also like a thing to note, like if you don't preserve your kombucha, it can turn black because it's like a natural material. So and even if it's like exposed to water, and if it's exposed to water and it's not covered with anything, it becomes really sticky and wet again. So that's just something.
Yeah. And that can kind of be an advantage, like we said, with like the stickers. You can use that as a tool, but yeah.
All right. Are there ways to combine different flora in your incubations to create different variants of material? We haven't explored with anything in combining mycelium. We have pressed flowers in between pieces of kombucha leather, though.
And I think the substrates that you're feeding the mycelium, like we said, we've tried like putting coffee grounds. Yeah, and it looks like it gets a lot smoother. And so that kind of changes the property right there, just what the mycelium is being fed.
We've also experimented with like combining kombucha and mycelium together, but our experiment wasn't really successful as it kind of developed some mold. But I think figuring out like what works and what doesn't is like a fun thing to do if you would like.
Okay. How do fungi help trees communicate in forests? Are they attached to tree roots or something?
Yeah, because I think it's like the systems, all those hyphae and the strands that extend underground. Because usually when you think of fungi, you just think of like the mushroom, but the main part of the organism is that system of hyphae. So I think those like connect the roots of the trees and kind of help send the signals between the trees.
Okay. Do you remember what it felt like to work with the material, and what responses do other people have? When we first started, we had zero experience, literally zero experience with what biomaterials were. I think some of us knew that kombucha was sold at stores, but that was pretty much the end of our knowledge. And like it was. I mean, for me, I can't. I'm not sure how it was for both Emily and Anne. It was just kind of weird, like playing around with like Scooby, because it was really it was a gooey, slimy material, and then kombucha, like working with mushrooms, was kind of odd to me at first, but yeah.
Yeah, and then as to what responses people have to the materials, those are always really fun to see. When we do some craft fairs with the younger children, especially, they're kind of freaked out by the mycelium because it's mushrooms. People are a little bit put off by the fact that kombucha is grown from bacteria and yeast, but we've had people try to eat it, so lots of big range of responses.
Oh yeah, you can also eat kombucha, but it's not recommended because it doesn't taste very good.
Just don't eat it plain. You can mix it into stuff, but don't eat it plain.
Yeah. Okay, how do you add color to the kombucha? So we use like soap dyes.
You can use food dyes too.
Yeah, food dyes, soap dyes, even natural like colors. We've only tried using beet juice, and it's like a very bright pink color, and it's like dyed our kombucha a bit. But any type of dye can be used to add color to kombucha.
Yeah, and you can both like put it in the actual culture, liquid culture while it's growing. I think sometimes it works better to paint it on right after you take the Scooby out, and it's really thick and wet. You can paint it on, it kind of absorbs it, but either one works. We haven't tried cabbage though, that's on here. But we've done beets. Yeah. What kind of feedback would be helpful for you if you were to try these activities at home?
I think the most valuable feedback is, were our instructions clear enough, or did you have to guess at each step? It's hard because normally when we go to do workshops, we already have things pre-grown, so we're not sure if our growing instructions are super clear. So if you do go try to grow either of these materials, we would really appreciate it if you could just send us an email or DM us on Instagram to let us know if any of our steps were confusing.
And if you also, because we want to make sure it's understandable for really young children, as well as like, we want to make sure it's understandable for like a wide range of people, because we want everyone to try playing with biomaterials. So feedback is really helpful.
Yeah, I think it'd be neat to find a way to like have a feed where we can share, because I'm sure other people have other tips that we don't know that would be neat to share. Okay.
I think as of now we have like our hashtag DIY BioBuddies on Instagram and on Twitter. So if you want to post like your different explorations with some feedback in it, you can do that as well.
We'd love to see what you guys make. It's always fun to see what, because people are so creative. It's insane. You guys are all awesome. Okay. How did we meet? What brought us together? That one's complicated.
Yeah.
I went to a summer camp that Emily's mom was the instructor for, and that's how we met. Trisha and Emily had been working together on design groups before that.
Mm-hmm. And then the other one is also kind of similar. How long have we been working? So we entered the 2019 Biodesign Challenge. So we started exploring together. And I think our first meeting was actually at the Tech Interactive, I think.
It was back in like September or October of 2019, a while ago.
2018, right?
2018, yeah.
Yeah.
Okay. Okay, what kinds of special equipment do you have to have at home to grow these materials? You don't really have to have special equipment, but just having like a clean workspace or like a tray that you can just keep all your biomaterial like growing explorations on would be good. And we also have like a list of all of the materials you'll need for each type of exploration or activities, and they're not that difficult to find. You can find them pretty much online or in different stores. It's just the biomaterials which might be a bit difficult to get.
Yeah, on our website, we have illustrated instructions, and it has the ingredients and all the steps in it. So, and yeah, most of it's designed to just be at-home materials. So, I don't know, the only thing like mason jars are kind of for like kombucha. Isopropyl, like rubbing alcohol spray is really helpful for biomaterials.
Latex gloves.
Mm. Yeah.
Okay. Can you print on kombucha to make biodegradable stickers?
We actually haven't tried printing on kombucha material, but we know that you can like laser cut like patterns onto the kombucha material, and that works fine. But you can also like cut out and like draw on your stickers. It might be a bit tedious, but it's fun to do.
We had not a question, but a comment that says kombucha leather enthusiast Slack channel. Great idea, yes.
Yeah.
Okay. Do you suppose that a glass-like material, silicate, could be made from incubated silica-rich algae? Ooh, I don't know. Does
Anya, if you know about it, would you like to chime in?
I'm with you guys. I don't have any extra insight, but it would be really interesting to see what materials could be produced from algae. Biology is great at making a whole variety of materials, and we just have to figure out how to harness them and use them. So great idea. Let us know when you figure out if it's possible.
Yeah, and you can go onto materium.com. I can enter in the link into the chat, and it's like a really big database of different types of biomaterials, and they have algae as a section, so you can kind of see what other people have made with it.
And then the how did we start working together? Yeah, we got together for the BioDesign Challenge, and we were all already interested in like design, bio, and making, so that helped. Next, I don't know for this one.
Next for each of you, do you want to pursue biodesign long term? That's kind of, we don't really know what we're going to be doing next. Hopefully, you know, developing our kit idea more and being involved in other biodesign projects. Anyone else want to explain?
Yeah, definitely staying engaged with the bio community. There's so many like cool conferences, people doing cool stuff out there. We were just part of BioJam, which was a really neat camp, and getting other youth engaged in it too. Yeah, we're still going to be looking on doing that.
Yeah, and just to clarify, biodesign, not biodesign, oh my god, BioJam is the Stanford Bioengineering Department program that just launched this year. So that one is just to get some more teens engaged in biodesign.
Yeah, and we've just been helping out with it. So that's kind of like another project that the three of us have also been involved in. Someone asked, have you ever thought of going on Shark Tank together?
No, I have not.
It seems kind of intimidating.
Yeah. Kind of a big leap from the really friendly biodesign community to Shark Tank, but sounds fun. I mean, I don't know if that's our forte.
We're also kind of like nearing the end, so if you have any like last minute questions, feel free to ask, but I think we'll be done after this last question.
Yeah, we'll answer this last one. Okay, do you look at nature differently since you began the project? Yes, definitely. I mean, before I was kind of like, ew, mushrooms, why, gross. And now I see a mushroom like growing on the lawn and my mom's like, pick it out. And I'm like, but it's a mushroom, it's beautiful. Yeah, it's interesting because the whole, the bio community, like we were talking about, is very focused on looking back to nature to solve climate change. So just seeing like the different ways that you see biomimicry in normal products too, I see that a lot more now.
I think it's really like opened our eyes to a lot of different things that we didn't really consider before, and you know, it's just cool to like see how you can incorporate nature into like art projects, design projects, biology, biodesign projects too. Yeah.
Okay, I think that's all the time we have for today. Sorry if we didn't get to your questions, but you can always email us at grybioBuddies.com. Oh, no, I can't talk, guys. grybioBuddies@gmail.com.
Yeah.
Thank you.
Okay. Well, thank you so much, Anne, Trisha, and Emily, for that really fantastic presentation and sharing all your work with us today. It always inspires me, and I love hearing about your journey and all the accomplishments that you guys have done in the last less than 2 years since we first met in the biotinkering lab. You guys are amazing. So thank you, and also thank you to the audience for listening in and asking so many amazing questions. This was really fun. And want to do one quick final thank you to our program supporters and remind everybody that there is another event next week, and we would love to see you there.